الآن نستكمل حل homework number 3. For now we are solving question number 2. Question number 2 says a transmission line has to be designed to carry an active power of 60 megawatt. So the active power, or P, is equal to 60 megawatt, which is 60 times 10 to the power 6 watts. Over a distance of 275 kilometers. So L, the length of the wire, is 275 kilometers, or 275,000 meter. The power factor is 0.9. And the conductor used in this line is, the type of conductor is AC SR. A, we are asked to determine the efficiency of the transmission line if the selected voltage, if V is equal to 169 kilovolt, and the resistance of the line R is equal to 14.75 ohms, ignoring corona loss. So if I want to find the losses which is W is equal to 3I squared into R. So from here we need to find I, which is P, which is 60 times 10 to the power 6 over square root of 3 times the voltage, which is 169,000, times the power factor, which is 0.9. So the current here will equal to 227.8 ampere. So this is the current. So the power loss is 3 times 227.8 square times the resistance, which is 14.75, and the power loss in the line is 2.29 megawatts. The efficiency is the output, which is 60, divided by the input, which is 60 plus the losses, times 100, and this will give me 96.32%. This is for A. For B, we have been asked to determine the efficiency of the transmission line if voltage is 230 kilovolt, changing the voltage from 169 to 230 kilovolt, and the resistance is the same. The resistance will not change. So the current here will equal to 60 times 10 to the power 6 divided by the square root of 3 times 230,000 times the resistance, which is 14.75, and this will give me a current of 167.35 ampere. Now we can find the losses, which is 3 times 167.35 square times the resistance, 14.75, and the power loss will be 1.24 megawatts. Now C, we have been asked to find, so yeah, if you want to find the efficiency, it's 60 divided by 60 plus 1.24 times 100, so we will get an improvement in the efficiency, which is 97.98%. In C, the resistance changed from 14.75 to 22.6 ohms. So the efficiency of the line will reduce. So first we find IL, 60 times 10 to the power 6 divided by square root of 3 times to 30,000 times the resistance, which times the power factor. Did I say the resistance? Times the power factor, here it's 0.9, and also, yeah, here is also 0.9. So we will have the same amount of current. The current will not change, which is 167.35 ampere, because the power factor didn't change. So the losses here will be 3 times 167.35 square times the resistance, which is 22.6, and this would equal to 1.9 megawatt. So the efficiency here will be 60 divided by 60 plus 1.9 times 100. It will give me about 96.9%. What will be the difference between line conductor used in part P and C? When we have a larger resistance, R in part B is less than R in part C. Thus, we have used the same type of conductor, we have the same length, and we have the same resistivity. The only thing changes the cross-sectional area. The cross-sectional area of the conductor in part B is greater than the cross-sectional area of the conductor in part C. So reducing cross-sectional area means we reduce the amount of conductors, or the amount of conductors used, meaning reducing the weight of the conductor, reducing the material used to make this conductor, and thus it will reduce the cost. So part E said, what is the advantage and disadvantage of using conductor with higher resistance? Higher resistance means less cross-sectional area, means less costly, so reduce the cost. This is number one. This is an advantage, as well as reducing the weight of the conductor. This is an advantage, and this will reduce the cost of the conductor, and it will also reduce the number of line supports. Number of line supports used will reduce because it's less in weight. So reducing the line supports and also as less strength will be used. For F, it is determined that the length of line conductor used will be 245 kilometers. Why the length of the conductor has to be more than distance covered by the line? Due to conductor sag. Due to conductor sag, this is the answer for part F, and this is the end of homework number 3.